Using factorial notation, the formulas for some sequences include products of consecutive positive integers. N factorial, written as n with an exclamation point, is the product of the positive integers from 1 to n. So for example, 4 factorial would be equal to 4 times 3 times 2 times 1. If you multiply all those together, it's going to give you 24. 5 factorial is going to be 5 times 4 times 3 times 2 times 1 is equal to 120. An example of formula containing a factorial is a subscript n, which is equal to parentheses n plus 1 factorial. Now, the sixth term of the sequence can be found by substituting 6 for n. So this would be a subscript 6, which is going to equal 6 plus 1 factorial. Well, 6 plus 1 is 7, so 7 factorial will be 7 times 6 times 5 times 4 times 3 times 2 times 1, which would give us 5,040. Now, the factorial of any whole number n is n times n minus 1 factorial. We can therefore also think of 5 factorial as 5 times 5 minus 1, which is 4. So that would be 5 times 4 factorial. So the definition of n factorial. N factorial is a mathematical operation that can be that can be defined using a recursive formula. The factorial of n, denoted by n factorial, is defined for a positive integer n as, well, anytime you see 0 factorial, that automatically is going to equal 1. Same thing with 1 factorial. 1 factorial is also equal to 1. N factorial is taken n times n minus 1 times n minus 2 all the way to 2 times 1 for when n is greater than or equal to 2. And again, going back to these two, the special case 0 factorial is defined as 0 factorial, which is equal to 1. So for example 7, we're going to writing the terms of a sequence using factorials. We're going to write the first 5 terms of the sequence defined by the explicit formula a subscript n, which is equal to 5n over n plus 2 factorial. So we're going to substitute n is equal to 1 through 5 in the formula. So when n is equal to 1, that's going to give us our first term, a subscript 1, and we're going to place n to be 1. So it's going to be 5 times 1 over 1 plus 2 factorial. Well, 5 times 1 is 5. 1 plus 2 is 3 factorial. So it's going to equal 5 in the numerator, and 3 factorial is 3 times 2 times 1, which is equal to 5 over 6. Next, we have n is equal to 2, so that's the second term. So it's going to be 5 times 2, which is 10 in the numerator, and then 2 plus 2 in the parentheses gives us 4 factorial. So we're going to get 10 over 4 times 3 times 2 times 1, which is equal to, well, we can simplify here. And when we want to simplify, we can see that 2 goes into 10 5 times. So we end up with 5 in the numerator, and 4 times 3 times 1 times 1 gives us 12. Next, we have n is equal to 3. So the third term is equal to 5 times n, which is 3, over 3 plus 2 factorial. Well, 5 times 3 is 15, and then we have 5 factorial, which is equal to 5 times 4 times 3 times 2 times 1. So keep in mind here that 5 times 3 is going to give us 15. So we have 1 left in our numerator. And then in the denominator, we have 1 times 4 times 1 times 2 times 1, which gives us 8. So the third term of this sequence is 1/8. Next, we have n is equal to 4. So the fourth term is going to equal 5 times 4, which is 20, over 4 plus 2 factorial, or 4 plus 2 is 6. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So we know that 5 times 4 is going to give us 20, and that's going to simplify what we have in the numerator, which is 20. So we have 1 left in the numerator, and then 6 times 1 times 3 times 2 times 1 gives us 36. So the fourth term is 1 over 36. Okay, next we have n is equal to 5, which gives us the fifth term. 5 times 5 is 25, and then 5 plus 2 gives us 7 factorial. Well, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And we can see that 5 is going to go into 25 5 times. So what's left in our numerator is 5, and then 7 times 6 times 1 times 4 times 3 times 2 times 1 gives us 1008. So therefore, the first 5 terms are 5/6, 5/12, 1/8, 1/36, and 5 or 1008. Now figure 7 shows the graph of the sequence. Notice that since factorials grow very quickly, the presence of the factorial term in the denominator results in the denominator becoming much larger than the numerator as n increases. So this means the quotient gets smaller, and as the plot of the term shows, the terms are decreasing and nearing 0. So if we go down here, it's getting closer to 0.